Hi, I'm Dan, and in this video I'm going to show you how to bind data so that it displays in your widgets on your screen. So the setup I've got here is the third-person template, and I've got a couple of things that I've made. So I've pre-made a HUD widget, which appears on the screen, and I'll quickly show you the elements of that in play. Here we are. So we've got a whole lot of stuff that's visible at the moment. There's text up here, switches remaining, time remaining. We'll see what that is in a minute. Well done, hurry, get the switches, get all the switches before the time runs out, and you're dead. Now, they're the different messages that are going to display at different points in time. And we'll have a look at that blueprint shortly. We've also got a switch blueprints, which is these shiny little blocks on the floor, and they're just a small blueprint class so that if you stand on them, it turns the light off. They have an exposed variable called on, which will tell you if the light's on or off. And what we're going to do is we're going to have a little game where there's a time limit, and it's going to tell us up at the top left how many switches are remaining to get. If we manage to get all the switches switched off within the time, we'll get the well done message. If we don't, we'll get the you're dead message. And when time's nearly run out, we'll be getting the hurry message. And the message, get all the switches before time runs out, will appear at the start of the game. So let's have a quick look in the HUD widget here. It's all very basic and straightforward. I haven't got any layout stuff going on here. They're just all absolute positioned. I'm just being a bit lazy here because I'm just using this for demonstration purposes. Okay. Let's expand that up. So the first thing we're going to do is we're going to deal with this time, actually. Fine. So I've actually built the timer already, and it's inside here. I've got a variable. Sorry, I flicked to the graph view of the widget. I've got a variable here, timer, and it starts at value. That's incorrect. You should start at value 1. And we're taking the delta time, and we're taking off a tenth of the delta time every time. And it goes through, as it goes through, and so this timer is going to hold a value between 1 ticking down to 0, and it'll take 10 seconds in order for it to do that. If we want to change the speed that it goes at, we need to change this variable here. So 0.1 gives us 10 seconds. If we just did 1, it would give us 1 second. So it's 1 over the amount of time that you want. Okay. So this is a variable. It's a floating point variable. We'll go back to our designer, and we've got this element here, which is a progress bar. And the progress bar has a value in it, which is the percentage, which shows how full or not full it is. And if we manually slide that, we can see full is 1, and empty is 0, and anywhere in between. So we'll start it as default at 0. But to the right here, there's this button, which is bind, which we can click on, and that has automatically detected that we've got a floating point variable that we could bind to. So I'm going to bind to this variable timer. There we go. And it should be just as straightforward as that. Let's check that that's working. So yes, the timer bar is slowly going down. When it gets to the bottom, it'll stop. So that's the first thing. If you just do data bindings, if you've got data that's sitting in variables inside your widget, you can access them if they're the right kind of variable to plug in. So that's the most straightforward binding. Most bindings are a little bit more complicated than that, and mostly we'll be using functions, and we'll be creating the functions as we go. So the next one I'm going to do is Actually, what I'm going to do just for now is I'm going to turn off most of these messages. So I'm just going to go down to the behavior visible, hidden, hurry, visible, hidden, your dad, visible, hidden. Okay. So the last message to hide is this one. Get all the switches before the time runs out. And same as the others, and turn that into hidden. Right. So what we're going to do is next is we're going to deal with this switches remaining, and we want this to display a count of how many switches are currently still switched on and are not switched off. So I'm going to put that value into the text box there. So before we create the binding, we're actually going to create some script which will do that calculation for us. So I'm going to create a new variable, which is going to be switches on, and this will be a integer, so that will be able to count. And what we're going to do is, in the event tick, is have a look and find out how many switches are still switched on. I'm going to do this in a pretty inefficient way, inefficient that should be, and every frame I'm going to go through all the switches and count them. In a commercial game, this would be too wasteful of processing time, but to do this in a more efficient way requires more interscript communication probably. So I just want to do it in a straightforward or simplest way as possible for now, because all I wanted really to do is to show this whole stuff. Okay. So this method would be fine for prototyping. So every frame, the first thing I need to do is I need to reset this number back to 0, so that it's counting from 0. Otherwise, it will just keep counting on the end of this this variable. Then what we're going to do is I'm going to get references to all of the switches. So get all actors of class, and this is a switch class, and it was just called switch. And then this gives an array of those switches. There's only 4 of them, and we're going to do for each loop in the array. So what's going to happen is we're going to test and see if it's on. So get on, and if it is, we're going to add 1 to the variable. So using the branch, and I'm just going to use the increments node for this. Plus plus, oh, plus plus, increments integer. So that node just adds 1 to the integer. Again. So that now should be a variable that's going to keep track of how many switches are on at any point in time. Compile that so that's available. And go back into the designer. And we've got the text block highlighted. And we want to go to the content here, which is text. At the moment it says text block. And we want to, got something I did previously in there. We're going to create a binding. So I confess what's happened here is that I have had to do this more than once, and I've had to reset it. So this is the get switch count text. We're not very good at capitals sometimes, so I'll just correct that. And actually, I'll rename this get switch count just to be a bit clearer. And all we need from what this needs as a return is text, because that's going to go into the text box. But all we need is this switches on variable, and if we plug it directly into there, it will give us an automatic conversion, so that node converts. Hopefully, that means that what should happen now when I click play is that all the 4 messages should have disappeared. Was it 4? Was it 5? And the count up at the top should be there. So, and that is correct. Let's just check that. So as I hit the switches, it is decreasing that count. I just about managed to get to 0 before that time runs out. So there we go, that's that bit done. So next, let's have a look at messages. Next I'm going to deal with the well done and the you're dead messages. And again, this is probably best done by having variables to help me. So I'm going to create a couple of variables. One is going to be called is dead. They're going to be Boolean variables. And the second one is one. Okay. And again, we're going to need some code to make sure that happens as is needed. So first of all, we need to remember that we need to come out of the completed node of the for each loop here, because we don't want to be doing this 4 times every loop. Once a loop is enough, again, it's still somewhat inefficient here. So what do we want for the logic? Let's do is dead first. And we're going to set is dead to be true if the timer runs out and there are any switches left. So there are 2 conditions here. The first one is that the timer is greater than or equal to 0. So greater than or equal to. And the second one is that when it reaches that point, if switches on is greater than 0. Switches on greater than 0. And I'm just going to combine those 2 together with an AND. Around a bit. And we're going to have a branch on this condition. So if this condition's true, then we're going to set the value of is dead to true. Okay. And the other one, which is has 1, that happens if the number of switches gets to 0 before the timer runs out. So we need the timer to be greater than or equal to 0. And the switches to be 0. 0. And once again, we're going to combine them with an AND. And have a branch. Oh, come on. And we're going to set has 1 to. Now, you might have noticed the thing that I've just done there is that I pulled it out of this here, but actually this is only going to happen if that condition was true. And if you're dead, you're not going to win. That condition isn't going to be true. I want to make sure I pull it out of this one here. I'm going to leave the other one in. It should never go through this route, but this is kind of belt and braces programming, making sure that whichever we've got for this bit of code will execute. So that's now got our 2 variables. They should be working, I hope, and we'll find out by creating bindings. So well done to be fixed onto has 1 variable. So I'm looking for it's the visibility that we want to bind and create binding. And that creates a function for us, like we had before. But in this case now, the return is a visibility type, which is an enumerated type. We've got various options here: visible, collapsed, hidden, etc. Okay, and we're doing this test on has 1. So we'll just do has 1 and a branch. And if has 1 is true, then we want that text to become visible. And the easiest way of creating the alternative is just to copy and paste the return node and feed that in there. And I'm going to do hidden on there. Okay. And I'm going to do the other one whilst I'm at it. before I test. Back to the designer, and that's the "you're dead" message. It's the visibility, it's binding. Now that other function we created, get visibility 0, has appeared as a possible bounding because that has the right kind of output, which is a visibility variable. But I don't want that, I want a different one. And in fact, what I should do is change that one. So that's the has one this visibility to this, and this is the is dead. And this is exactly like the other one, but it uses the is dead variable instead. Copy that. Change this output to hidden. Compile that. Now I'm going to see if it works. So set up these bindings. They should make those messages appear when it's appropriate. So let's play. Oh, so I've got something wrong already because "you're dead" has appeared. So let's stop and go back into our logic. Now I suspect that that's the not the not the not this. Let's just check. Is dead. True is visible. False is hidden. I think it must be in our event graph in this logic here. So is dead gets set to true if the timer is if this should be less than or equal to. I've got my logic here wrong. Less than or equal to 0. The reason why I'm doing less than or equal to is because as it counts down, it might slightly tick past 0 and go to a slight negative number. With floating point numbers, it's always wise to use a less than or equals or a greater than equals rather than an absolute equals because it might just miss that value. So hopefully I've got no more errors. And try so it's not appeared anymore. I'm just going to let the timer run out. La la la. 10 seconds isn't very long. There you are, the "you're dead" appears. And I'm going to restart that. If this was a more sophisticated game, something else would happen as well as that. But again, this is just to show the functioning of the HUD. That's got the switches and the well done's come up. And the timer's run out and our "you're dead" message hasn't come up because the logic precludes it from doing so. Okay, so what's next? Back into our HUD widget. Let's have a look. I'm going to do hurry next. So hurry is going to be based on, this is some text that's going to come up when you're getting towards when the timer gets towards the end. And I'm going to make it appear in the last 3 seconds. So I want another binding on the visibility of this. Behavior, I'm missing it. Visibility bind. I'm going to create binding and it'll create another function here. And I'm going to call it hurry. So what I want to happen is I want this to be visible when the timer, right, remember the timer is a number between 1 and 0. And it starts at 1 and it goes down to 0. So if the timer is less than 0.3 but greater than 0, that's the last 3 seconds. So let's get the timer variable. And we're going to do a test if it's less than. And we are going to do less than because it's when we don't want to hit an exact value. It's just when it ticks over that value. And we're going to use less than 0.3. And the other condition is also based on timer, so I can pull out from there and greater than 0. And we can combine those with an and we'll have a similar branch to how we had before, the previous 2. And copy that. Compile, and we'll test that. So here we go. Waiting. Switch one of the switches just as we can. And that hasn't come up. Now, why hasn't that come up? Let's go back in and look at that. So back into the code. So this is the visibility. We've got checked the outputs. We've got a visible and we've got a hidden. If the timer is less than, we haven't plugged in this greater than into the end. So that would always be false. So that's why it's not coming up. Small connection error. Hopefully that's it. Touch wood. Try again. Should be about now. Yes, there we go. Hurry. Then it'll disappear just before we get your death. It would be nice, it'd be kind of more urgent if that flashed. So let's make that happen. So let's go back into that. I'm going to use a mathematical trick here to do that. So what we want is for it to flash several times before it then turns off at the when it gets to the final place. I have done this previously, so I've worked out some values that will work for this. And much as I dislike just doing this is the thing that works, I will explain what it is and how it does it. So I'll just put the nodes in and then I'll explain them. Two and and we're going to add that as another condition. There we go. Right, so I told you I'd explain this. So what we've got is, for the time, we've got a number that starts at 1 and goes down to 0. Okay? So if we multiply by 50, that then means we now have as an output here a number that starts at 50 and goes down to 0. So this percent is it's called modulo, and what it does is it divides by whatever number you give here, and then the result is the remainder after that division has been done. It does an integer division. It doesn't have to be, it can be a floating point, but we've used an integer here. So it tells you how much is left over afterwards. So this is going to give us a number that varies between 0 and 2. And what's going to happen as this 50 comes down to 0 is that at 50, this will give us a 0 output. And then at 49.9, that will give us a 1.9 output here. And as that comes down to 49, that'll give us a 1 output here. And 48.9, it'll give us 0.9 here. And coming down until we get to 48. And then at 48, it will then it'll be a 0. 47.9, it's back to 1.9 here. So this is cycling through numbers that come from 1.9999 at the highest down to 0, and it will do it 25 times. And the way that that's been defined as 25 is because I've used 50 here and I've used 2 here. Okay. Now I could have used other values, but this set of values means that if we had this text visible for the whole of the 10 seconds, over that span of the 10 seconds, because we've divided by 50 and then modulated by 2, it would give us that range from 1.99 down to 0 25 times. Now, we're only actually going to be using it in the last 3 seconds, but there's 25 times in 10 seconds gives us about 2.5 times per second. So this means this is going to flash 2.5 times per second. And in order to make it flash, what I'm then doing is I'm comparing it with the value 1. So for the point in time where this value that's between just under 2 and 0, as it comes down from 1.99 down to 1, this is true. Once it's past it, it becomes false. But then when it gets to the next cycle, it becomes true again, then false again, true again, false again, and therefore we get the flashing. If you don't follow the maths and the logic for that, don't worry about it. This is just a little tricky thing that I'm putting in here. Now, having explained all that, I'm hoping that it is going to work first time and I haven't made any mistakes. Let's test it out. Okay, so the timer's going down. And we get our hurry coming up. And it's flashing, and it's quite a nice speed on the flashing, so I'm happy to leave it at that. Okay. Right, we've got one last message to deal with in the widget, and that is, excuse me, the get all switches before the time runs out. So, once again, I want to do something a little bit tricky with this. What I like to do is for it to be visible for the first 3 seconds of our mini game, and then fade out. So we have, for all the others, I've used the visibility, and I'm going to switch the visibility back in to visible to start off with. And actually what I'm wanting to use is this render opacity. Okay, so this is actually takes a value between 0 and 1, and as I bring it down from 1 to 0, it becomes invisible. So this allows us to do a fade. Okay. Now, 2 things that need to be noted here. First of all, I can actually take that below 0, and it's fine. It doesn't worry about it. It just caps it to 0. Similarly, if I take it beyond 1, it takes that as being fully visible, and so it can cap it at 1. So again, that's fine. However, the problem that I've got here is the lack of a bind button over here. So you can't actually bind your render opacity to something. So instead, I'm going to have to do it with code that pushes that information rather than pulls the information. Not a problem though. We're going to be fine. So the first thing I want to do is I want to take that, get that, and I've had to backtrack on this. Right. No, that's fine. Get all that. Now somewhere it's at the top here. There's a box that I can click that says it's a variable, so I can make that text box accessible. I need to do that to make it accessible to my graph. Okay. I'm going to go back into my event graph here. We've had all this logic, and once again, we're going to want to do some logic to make this happen. Right. So, visible for the first 3 seconds, and then fading out. So I've got a, so I have done this previously. It's a bit of tricky maths to make this happen. So we're going to use the timer again, get that value. And to make this easier to deal with, I'm going to multiply it by 10. Multiply by 10. So that's now going to give me a value of 10 down to 0 as it goes through, because that timer goes from 1 down to 0. Okay, so our opacity, if we did that and we just plug this straight in, this would be visible completely for the first 9 seconds until this hits the value 1. And then in the 9th second, it will fade out until we get to 0. But what we wanted to do is we wanted to do that at the point where we hit 3 seconds instead. So I'm going to just take the number 7 off this. Minus 7. Okay, so the output from this is a number now that's between, so 10 minus 7 is between 3 and minus 7. And for the first 3 seconds, it'll be coming down from 3 to 0. For the first 2 seconds, that's a number greater than 1. So it will fade down to, do you want it 2 seconds or 3 seconds? I can change this by changing the number. I'm going to have it 2 seconds and then fade. just because I've got my 7 in here. So the first 2 seconds, it'll be a visibility that's greater than 1. In the third second, it will go from 1 down to 0. And after that, it'll be a negative number, and so it'll still be visibility 0. So we should be able to plug this straight into that visibility. There's the text block. Having created it as a variable, I can now drag that in, and I want to set render opacity, which is that value. And once again, whatever our logic was before, we want to make sure we're coming out of both those pins there. And this plugs straight in there. So this is doing the same kind of thing where we're making the elements in the HUD, this element in the HUD responds to some values of things that are going on elsewhere, but it's doing it without a binding. And actually, the fact that this doesn't have a binding is a little bit of a pain, but it does get me to demonstrate the fact that you don't have to use bindings. You can do it in another way. So, hopefully, that's what's going to happen. Get all switches before the time runs out, and that fades. That looks nice, right? So I'm just going to have another attempt at my game and see if everything's working. Get my switches switched. Oh, I've been so good with the time. Am I going to make it? Yes, my hurry. Well done. The hurry's gone away. Possibly I need to do a thing on the hurry, which means if I hit the well done, then it takes the hurry away, because that's illogical. But you've seen various ways of doing bindings. We can use variables, we can use functions, we can access things from elsewhere, and we can just do direct manipulation of the elements of the HUD. And that's it from me for now.